Hi all. So welcome to another day on this JMeter training. And as a recap, we have discussed till we are discussing the core points, right? And we have discussed till here till cache cookies and user session. Today we'll talk about server side and client side, right? Or UI concept. And then if time is left, we'll see these topics also. So yeah. So server side and client side, right? Concept in performance testing. So this is related to what we have discussed till now. Plus, this will answer a query, right? That was asked by one of the participant. She was a lady. I think she has not joined today. So maybe she will get the answer today as well. That query was like we have talked about request and then each request having embedded resources, right? So, mm, yeah. So in she asked like in doing performance testing, we we should also consider the time for those embedded resources, right? So all these three, all thing we will be discussing today. Let me open this inspect and just a second. I'll clear everything just to have a fresh view. All previous stuff clear. Now, uh, it's www.amazon.in. Okay. So what is this client side and server side? Okay. So see this stuff when we sent a request. Here also you can see two requests were fired, but this is the main request, right? You can see the type document, even size is more. The size of the main request will be more compared to all the size that are downside. Then uh, their time, okay, time also. So and plus it will be bringing the response, the expected response, which will be in code format. Correct. Now, what is this stuff? So see, there are three kinds of response time in performance testing. Okay, in performance testing. First is pure server side response time. Now, what is that? So, suppose this request went, right? And this request went, and we had this. This is the request which went, and it went to the server, right? This request went to the server. This, yeah. So this request went to the server, right? And server, and then response came. A response. So this is a request and this is a response, right? So response came in code format, uh, right? We know that, and it took some time. So that time it's displayed, let us say 1.21 second, right? Okay. So this time that you see, it's called T1, and it's a pure T1. Suppose we'll take this value as a T1 as a reference value. So this is a pure server side response time. Means in how many seconds server has responded exactly to you. And in performance testing, remember generally the focus is to measure this stuff one. just hitting the endpoint. Endpoint means right? Endpoint means hitting the request, maybe for one user, for 100 user, for 1,000 users, right? Whatever, and getting the response, which will be in code format, and how much time it is taking, either for one user or for 100 or 1,000. So that is generally this is the part we talk about in performance. Even in API testing. Okay, API is nothing but they are also endpoints. There also URLs are there, requests are there. But in API, this whole concept is not there. Like, do you see embedded resources concept? And this is only part of web application. When we talk about API, they are just endpoint. We do not talk about this embedded resources stuff and uh, dependency of the requests, right? Yesterday, we day before yesterday, means the last session and the day before the last session, okay, where we talked about a transaction can have multiple requests. So this concept of transaction is there in only in web application. Okay, in API, it's not like that. API, all requests are independent. So we will see when we talk about API testing. So there also only the request is supposed to go, and the response which will be coming, and how much response time it's taking here also. Here also same thing. Only difference what happens in API and EY script, like web application script. Here a complete flow is there from a start to end. You have to do the flow, and the transaction are dependent on each they are dependent on each other, like first home page, then you will be selecting a product, then sign in. So this is dependent, right? This is called dependency. Even here transaction concept comes. A transaction can have multiple requests, all those things comes in API. That kind of dependency of scenario is not there. APIs are there, okay, but not in exact format, how it is there in web application. Plus they are just endpoints, single and standalone endpoints, right? And their transaction concept is not there. So okay, so in API testing also, or here also, generally our focus is on getting this time, which is you can see here also. And the same thing is can be done in tool, where we just hit for one user or 100 user or 1,000 user. Let us say this home page launch only, and we calculate, we try to find the time for that many users, right? And this is called pure server response time or server side response time. Understand? So, and this is T1. Next, once this comes, once this response comes, this code comes to the browser, then this whole thing is um, the code is processed and whole the stuff is downloaded, and yeah, they are retrieve and download, and whole thing processing happens. So this time, right? So there is a separate time for that, and that time you can see here download of embedded resources. Sometime in millisecond it's showing, right, for them. So that retrieving and how much time it has took for that, correct? So that you can take is T2. Okay, there will be some time for all of them retrieving and processing, and that will be T2, right? So T2, and then once all get downloaded and when we get the final page, so there is some separate time for that also. So we can take that as a T3. Right? Now this T2 and this T3, this is called user side activity or client side activity. Client means user. Remember, in whenever we that is what server and client. Okay, so here do not think client means the project owner. No, a client means the user. User is client, and client server. Server is that application, right? So this stuff happens at user end or at client end. Means only see, server has sent the response. Now this downloading and other thing is done by the browser, and processing and all thing is done by the browser in a client laptop, in user laptop, right, or user machine. So that's why this T2 and T3, you see, that is not. it's not always the part of core performance testing. Means, as I said, this is considered in core performance testing. This is called UI part, or you can say UI performance testing, user interface. Okay, how much time it is taking in user side for all this thing happening, right? So that's why since this all two stuff happens on user end, so uh, this comes under part of UI testing or yeah, user interface, or that is also called as client side performance testing. You might have heard. Okay, or going forward you will be hearing. So whenever you'll be hearing this word, you will not be confused now because you understand, right? UI performance testing or client side performance testing and what is servers. It's nothing. It's just a difference between the response time uh, for the different activity. One activity is this one. First activity is this one. Then second activity is there is a download of the DOM content and then all embedded resources and whole thing happens, right? So this two T2 and T3 happens at user end. And what happens? People generally do not, in many projects, people do not focus much on this because it's a part of user side. Suppose a user laptop or user internet is slow, user laptop, user RAM, user processors, they are slow. So obviously website will load slowly because all this activity takes time, right? Takes time. If all these things are fast, it will be faster at the user end, right? So that happens, right? So since here some factor comes from a user laptop or user machine as well. It's dependent on user machine configuration. So any suppose you see some slowness, you cannot directly blame on server, correct? Because if user laptop is poor, right, his RAM is poor, his processor is poor, obviously there will be more increased response time, right? So for now, do you see on my laptop, this page took 1.21 second only, right? But total time it has taken 5 second. I'll show you where is that 5 second. Okay, fine. So this is the request went and response came, and how much time it takes for that. I'm talking about every request or every transaction, right? So this is what server side response time, and this is let us say you can call as a T1. Then there are T2, and then there are T3. T3, T2, and T3. Now, when we make them, sum them up, all right. So T1 plus T2 plus T3, right? When we sum up them all, okay. So whatever the time we get, that is called end-to-end response time. Okay, end to end. Okay, and response time or complete response time also you can say. So you see there are three response time. Now the first one is here when this whole thing is loaded and processing. So web structure is built, that is called as DOM content load, and how much time it has taken you can see here, right? You see, and then final time after all image and everything got loaded, this is the final time, right? So this final time you see 5.10 second is is addition of 1.21, and apart from that all every activity, the processing, the load of a structure which is called as DOM, then then all retrieving of embedded resources, right? Okay. Now coming to the point, so as I said, like in most of the cases, we only focus here in all most of the part, like in core performance testing, even in API. Only when people or the client, now client means I'm talking about project owner for which you are working, if they want to focus on the UI side or client side also, then we think about this. Okay, this as well. And what I told that since this time depends mostly on the user laptop also, so we cannot blame everything to the server, correct? So what happens? That's why this part is sometimes it is not considered mostly. Okay, in any performance, mostly I'm saying, or you can say this is considered secondary part. First part is this one. All right. Now, yeah. So hope you got right. So you will always see the main request time will be very less. Then this DOM content time will be little high, and then this total time will be the sum of everything, which will be maximal. Do not focus on this finish now. This is something different. No need to worry about. Okay. So this is what. Okay. So there are. This is what client side and server side concept in performance testing. Okay. Now, when this so answering to that question asked by that lady, that do we consider embedded resources response time also in performance testing or not, right? Or this whole response. So now you got the answer, right? That in general, whenever we do a performance testing, the core performance testing major focus is on finding this time only. You send the request, you receive the response, and how much time it took for one user, for 100 user, for 1,000 users, for 10,000 users. That we do. Okay. Only if the project owners, right, whoever is the project owner, they want that, hey, let's focus on this part also, like how much time it is taking in processing and retrieving of embedded resource. That is called total response time, right? Then you can go ahead and do this part as well, right? So both thing can be done in JMeter. I'll be showing you. This is always done. Then in JMeter, how to retrieve embedded resources, and when you retrieve embedded resources, obviously time will increase, right? So that also you can do. Okay. And then there is a concept called Lighthouse also, which is a default plugin of um, uh, Google Chrome browser. Okay, Google Chrome, it's there. And it is generally used to analyze the page, any page performance you can, right? Analyze page means the on UI side, right? So even you can use it. Suppose I'll do that, right? For desktop, it will do something or auto select. I'll click on analyze page. So what it will do, it will reload this page. You will observe, and then it will try to analyze and tell you that um, what is good, what is not good. So I'll click. It's analyzing. So do you see here page is getting reloaded, right? And it's analyzing. And it will give you a report to you. You can download also. So this tool also you can use for the client side, getting the client side matrix. Like on client side, if you want to get in detail for that page, what is happening. So this is a free tool which helps in doing that. Right, whole analysis we can get it. You can see here it has generated a report, right? And you can just scroll it. Uh, so everything. Suppose anything taking time, it has all highlighted in red, right? And we can just scroll each down and read that uh, uh, what what it is trying to say for that page. Okay, on that page, because see, on client side means what, when the code came, then after downloading of embedded resources, when whole processing happens, then something can go slow. Maybe a JavaScript file, JS file, it's loading, or an image loading, that can be slow. Okay. So if, right, so this thing comes in the main the role of embedded resources. Okay, how fast the JavaScript is getting loaded, how fast the CSS is getting loaded, how fast the image is getting loaded. Any image over there is slow to load, right? So that is what we consider in UI performance testing, right? So that all you can get idea through this lighthouse also. For every page, right? It will give you right. So suppose one about some JavaScript here, it's saying that you can try to reduce the JavaScript execution. Okay. Uh, uh, and that also they will tell you, right? Some link also here there is. telling. Correct. So we need to expend some time to analyze all this thing. Okay. So that you can understand after you understand the main whole course stuff. So likewise, okay. So what it even it gives a what we say a solution as well, like what you want to do if there is any issue, right? So that one. Okay. So this we can use for checking the stuff on client side. Okay. See in JMeter, we can the request that went, right? The response that came, that we can always do. Then if you try to download embedded resources and how much time it's taking, that also we can do. But there is something called processing of the stuff, right? Java, script, and other thing. So this all thing needs a very detailed analysis because every page has all this so much stuff, right? So every it needs it takes time because every so many components are there on each page, right? So one by one you have to figure out one by one for every page you have to do it, right? So that is what the core difference between client side and server side. And always remember that servers client side stuff is only done when the requirement is there, when people say or the project owner is saying let us do that also. So hope you got the idea what we do in that, how to do, right? And we can take help of this free tool also to do that, plus from JMeter also we can do. Okay. So we can combine both the stuff, the JMeter stuff and then Lighthouse, and you can do the client side thing also. Client side is generally when people do that, let us say, suppose the request was there, right? And response came. Just now we have seen that response was almost like 1.21 second. In that only the code has came. But after that, on user side, on client side, whole processing and everything is taking very high time, like suppose 10 seconds, right? So this is very fast, but this is very slow or time taking. So there, we then the focus shift from here to here. That okay, this is done, this is good. Now let us try to fix this issue. Client side, why this is? Then what you have to do? You have to run this on multiple laptops or a laptop which will have a good configuration, right? At least on an average configuration, what a normal user nowadays they have, right? So considering that you have to run the test on those laptops and then you have to check how much it is taking. Is it taking 10 second every time? So if it is taking 10 second every time, then where is that problem? What components are taking 10 second, right? In all those list of embedded resources, which you can get through Lighthouse as well. You can see for every page. Then you can point those thing out, and then they can you can sit with the development team, and then they will try to fix. If something can be done in its fixing, people will try to fix the stuff and try to reduce the uh, thing. Okay, so this is how these stuffs are done. So hope you got a clear picture about server side response time, client side response time, end-to-end response time. What is end-to-end response? Or you can say total response time. Here also we can see one is DOM content load, one is total load time, right? What is that? And the main server time will be shown here for that request, right? Then yeah, so that is done. Next, we will talk about next topic, which is application architecture. So so every application have a architecture like client server architecture. Say there is design and different layers also. Now, what do we mean by architecture, right? Architecture means a setup, a blueprint, how application is made, or you can think like what different tools and technologies are used to make that application. Okay, and how many numbers of servers are there. So this is called architecture. Every application has some architecture, right? A blueprint, right? So in general, there are basically three layers which are the foundation of an application architecture. Okay, they are PL layer, presentation layer. So we will talk about this going forward slowly one by one. So PL layer, presentation layer, then BL layer, business logic layer, and DML layer, data manipulation layer, or you can also call it a presentation tier, logic tier, or data tier. Okay, so these are the different layers, and then there are n type designs are there. So in design, uh, we have one tier. So four types of application entire architecture are there. First is one tier architecture, two tier architecture, three tier architecture, and multi tier architecture. So we'll try to understand about each. Mm, Just give me 1 minute. Just the one. Okay. So first is one tier architecture. So one tier architecture used to be existing long back when computer world was just initially it was in a starting phase, right? That time this one time architecture were there. So in one tier architecture, what used to happen, like everything used to be there on the client, mean one machine only. Client here means user machine, so only one machine, every components will be there, one single machine. Okay, so that was called as client tier nowadays also client tier architecture. You can say, like, suppose you are making demo project, or in our engineering we prepare a small projects, right, for semester exam. So that time we keep everything on one symbol, uh, one system, right? Correct. So you are getting the point. On single system we keep all those things. So that is, you can take it a example of client tier, one tier. So long back when internet world was not there and everything, internet came very late, right? Computer world is there in from very long time. So what used to be there, that on single machine earlier, if you remember old computers images, if you have seen, they were so big, right? Even a simple floppy disk, how big it is, it used to be. One computer means one single room, okay, will fill up with that stuff, right? If you are aware, or if you are not aware, you can just Google like how long back a computer, a personal computer look like. Okay, so that time internet thing was not there, and everything used to be there on a single machine. Now we have, next is two tier architecture. So in two tier architecture, there are two layers, two separate layers are there. One is at user end and one is at server end. Okay, and this architecture is still there. Our mobile application follows this architecture. Okay, so we will talk about this. First, let us understand three tier architecture. If you are, so three tier architecture. So current all the applications, right? They follow this three tier architecture currently. In three tier architecture, there are three layers. Three layers. Presentation layer, PL layer, business logic layer, PLL layer, and DML, data layer or data manipulation. Now, in PL layer. What is in PL layer? So all three layers are separate, kept separate. This is also called a distributed architecture. Okay. This is called as what? Distributed architecture. Now, what is there in PL? What is this PL layer? Okay, so PL layer means the user interface. Okay, and which is also static in nature. Suppose I'll open one banking website. Let us say ICICI. So this front end, okay, or presentation layer. Presentation layer means PL means presentation layer. Presentation means which is presented to the user, which is what presented to the user, right? To the user. So when a user is accessing this website, this is the presented part. We are getting this presented from server side to us, right? This is also called as front end. Okay, you might have heard of front end developer, right? So front end. So this is called presentation layer, right? Or front end, or this is also called a UI, user interface. User interface. You might have heard of UI UX developer, right? So Uh, okay. And in front end part, what will the look and feel and the tabs, which doesn't change, which is change means right, which are static in nature. Static means they are same and they are common for every user. Those all things are the part of presentation layer. Okay, they are all part of presentation. So if you see this page, or suppose if I go to the login and if I click on login, so again this login page, right, which is here, right. So this is part of presentation layer, right? So you got the idea, right? What is presentation? Now, tools and technologies used to develop presentation layer are here: HTML, CSS, and JavaScript. These three are very common. And then apart from that, we have React, Vue, Angular. These all are there. This presentation layer is also called as front end, right? And the especially the developers, right, who develop this layer, they are called front end developer. You might have heard of this every now and front end. Or this is also called UI. Nowadays, there is a term for front end developer, which is called UI UX. Okay, user interface, user experience developers. So the same thing, right? And these are the tools and technology used to develop that layer of any application. Right? Then comes a business layer, business logic layer, BLL. Now, what is BLL layer? So in BLL layer, so business logic layer. Now, what we understand about business logic layer, right? So all the application logic or the all application functionality, right? That okay. So we have this application. Let us say banking application, and when you do the username, enter username password, we enter in the dashboard page. Now, what a user does. So many things are there, right? Many logical activities are there. Transfer of money, adding account, deleting account. Okay, then uh, putting logical condition, right, user payment. So you see different uh, functionalities is there, right, functionalities. And to do that all functionality, we have to write a separate code for that, for separate coding, which does the logical activity. That's why it is also called a brain, means logical activity, correct, for of that application, of that business scenario, whatever the, all logical thing is done there. Correct. So for that, uh, that complex code is there, right? And that's why this is also called as backend, right? It is called as backend. Okay, backend. Okay, and but in general term, it is called logic layer because into there can be so many scenarios, right? So to do those scenario, we have to write the whole code for that, right? Suppose you want to add users, you want to delete users, you want to add beneficiary, you want to transfer money, you want to set up a auto pay of your credit card EMI, right? All those things. So these need some hard complex coding, right? Complex coding. So that's what this is called as whole business functionality logic uh, is there in this layer, right? And it is called as PLL layer, right? Business logic layer. Okay. So what are the different tools and technologies which are used to design this layer are Python, Java, PHP, .NET, Ruby on Rails, and uh, so Python, Java, PHP, Golang is there, Go, Ruby on Rails, and so this those people who design this layer, this is also called as backend. Backend of this is front end, and this is backend, backend, backend part. Okay, and people or developer who are responsible for designing this layer, this part are called backend developers. Okay, so you might have heard of this backend developer word as well, right? Java developer .NET. So what they do, they are basically designing the backend part, okay, which is more complex, and hence, yeah, these jobs are very huge in demand as right? More hardcore coding is needed. Okay, then comes the database. So database is everything, right? So whole thing is whole thing is stored in data. Even your photo, transaction, message, everything has to be stored in data. Your whole history, whether you are using a banking application or you are using a Facebook or you are using a Gmail, right? So whole thing, right? Your all mailbox, Gmail mailbox, somewhere it is getting stored. Facebook, so all the post messages, pictures, right? If you are using Instagram, anything, banking app, all our transaction history, and so all is record, right? All is data. So somewhere this all data has to be there. So that is what very crucial layer. That is database layer, okay, or data layer or data tier layer, right? So different database technologies are there, so like PostgreSQL, Microsoft SQL Server, MySQL, Oracle, and this. So this is database layer, and the developers. So the database developers, there is separate role you might have heard of, right? Who design the database, correct, of uh, of any application, right? So these are what three different components. Now, uh, anywhere. So see now what happens is these all layers are kept on different machines, and that is called as distributed architecture. So this layer where the front end or yeah this front end or PL layer will be kept, the machine on which this will be kept, that those are called web servers. Okay, web servers. Then this whole setup code and backend or thing wherever it is kept, those machines are called as app servers, application servers. Okay, app servers. And then this setup where it is called, those are called database servers, DB servers. Now we have say multi-tier architecture, which is extended version of this three-tier architecture. So in that, what happens? There are multiple same web servers, multiple app servers, and multiple database. And now you'll understand why this distributed architecture is there and why they are kept on different servers and why there are multiple servers, right? So this see distributed architectures are the modern day architecture, right? Why? Because they are why they are modern day architecture. Suppose let us take an example that in this world everything has a capacity. Okay, even if you have a capacity, I have a capacity, so everything has a capacity of anything. Suppose let us say you can pick 30 kg weight, right, with a very ease. Ease means with very convenient. Suppose someone can pick 30 kg weight, someone can pick 25 kg weight, someone can pick 20 kg only, right? Someone can pick 40 kg also without any issue. Correct. So capacity, or let us say, suppose there is a 100 meter run or 100 meter race is going on. So again, there will be also capacity or marathon is going on, right? So everything in this world has a capacity. Even my laptop, personal laptop, everything, right? Every device, everything. So in this world, everything has a capacity. Correct. So same way, this servers has a capacity. So suppose there is one server. Uh, you know what is the meaning of server, right? Server we have just discussed in the beginning. It is a combination of CPU and hardware, uh, and then inside that OS and the application will be kept. So let us say there is one server, and everything you have kept as a best thing. Means a best server you have kept, best motherboard, best memories, 64-bit memory, and everything you have kept as a best. Then you have deployed one your web server in that, right? So this is one server. But even though that will be having a capacity. So suppose an example that you have one web server which can handle 5,000 user load, right? 5,000 user load per hour, right? Per hour or per second, whatever we can take, anything we can take, just for understanding. So per second, right? In 1 second, 5,000 user load. Now, what is the meaning of user load? Means the request, right? The request which is coming. So suppose Amazon.com. So 5,000 user at a time they are accessing Amazon.com. So it can handle it. It is replying to them, and even response time is also fast. Correct. So it means that that is what you can think. Okay, one server capacity, handling capacity per second is suppose 5,000 with very convenience, right? That is called ease. There is no slowness, there is no server issue, right? Everything is going good. So one server can handle, let us say, 5,000 requests per second. Now, suppose there are 20,000 users per second on Amazon. Means on Amazon, every 1 second, 20,000 users are sending request. Okay. Suppose let us say Amazon.com. Only they are suppose opening www.amazon for an example. They can send anything, any request, but just for understanding, right? So 20,000 users per second means 1 second, 20,000 requests is going. Understand? Now, if one server has a capacity of only 5,000, so how he will be able to handle 20,000 user load, right? Not possible. So that is where it can crash. If there is only one server, it can crash. And when it crashes, we can see those error like 500 series error. A few days back only we have discussed internal server error, bad gateway error, right? Those forbidden service unavailable, right? Gateway timeout. Those kind of error will come. Even response time also you'll see it has increased very high, very much. Okay. So that is where we put up multiple servers. Suppose multiple web server, multiple app server, multiple DB, just to cater this user load, right? Extra that much user load, how much it is required, right? And hence it is called distributed architecture, because everything is so that way we have. So you see there is increase in server, web server separate, app server separate, DB server separate. Then in that also there are different many numbers are there, right? Many numbers. So this is what modern day architecture of any application. Now in that, so many other things are also there. So one example, like say, let us say load balancer will be there. Load balancer, so it will be there. Load balancer uh, uh, do what? They balances the load. So meaning of this is, let us say that there are three servers here, and how we will how anyone come to know that which server is busy at how much level, right? Means suppose this server is full, it is handling all 5K, but this server is somewhat empty, right? It's handling 3K currently, so it has still capacity of 2K. This is handling 1K, it has still more capacity. So how this all is managed and how anyone will be knowing, right? So this load balancer, if you see every before everything they are there, which manages this loads at this web server, and they see which which server is at how much capacity, and if requests are going, so that request needs to be sent to which server, this first server or second server or third server, depending on which free, right? So this is there. Then there are many other stuff in an application architecture. Firewall is there, proxy is there. Okay, so those things are there. But on high level, this is what. So this is what I have written here. You can say presentation layer receives display input, receive input, display output. Then logical calculation happens in application layer, and storage and managing of data happens last time. Right, same thing uh, given here. Right. So do you see here one thing that the interaction is done through presentation layer only. So how anything happens is we will see. We'll try to just understand. See, this is the first layer. Okay, presentation layer, and any user interacts with the presentation layer, right? On anything presentation layer. So any request. So this is presentation layer. Suppose you got ICSC, you have open ICSC, and then you are on login page of ICSC. So you will be entering username and you will be entering password, and then you will be sending the request. So that send request carrying the username and password as payload will be coming at this layer only, right? At this layer only, through this layer, right? First through this layer, and it will come to this logic layer. Now let us say here it will be processed. That request will be processed. So let us say that request is a verification request, right? That you have sent the request to verify. So immediately what will happen? The server here, the logic, they will take the existing username password. Means if any saved username password already there, it will take from DB and then try to match it here. Suppose it matches, right? What you have sent and what is there, it matches. So it means you are successful login. Then immediately they will send then immediately it will collect whatever data needs to be displayed to you, and it will process, and immediately it will send back to you through the presentation layer, right? So that is where when we log in, then we get a dashboard page, and on dashboard page, suppose 1 lakh people are logging in or 10,000 people are logging in, right? So every user will get his own dashboard, right? So from where it is coming, right? That is through database, the thing. So you will be getting your own account information, I'll be getting my account information, right? So this is how a processing happens. Suppose username got verified, then data is fetched and then shown to you, okay, this is your account, this is some other people account. So same way, let us say Facebook or Gmail, right? So if you log in, then you will be getting your own inbox, then someone else will be getting their inbox, like that. This happens. Okay, now um, okay, so this is not about login only, any other request. Suppose you have logged in, then you want to transfer some money. So let us say you have sent a request to transfer the money, it will go here, then immediately server will send you an OTP. You have to enter the OTP. OTP will come again here, server will verify that, and then he will transfer that amount to someone, right? The all thing happens here. Now once that amount is transferred to someone, so from your main balance that much amount will be deducted, right? Like that whole thing happens. So now thin client and thick client. So thin client application and thick client or fat client application. So see, all web application or all application which uses browser to access, right, to get access. Those are called thin client application. Thin client application has a proper three-tier architecture, right? So, uh, yeah, proper three-tier architecture. Layer one, that is called presentation layer, is on client side or on user side, user facing. Okay, and it is not installed. Remember, this I'll be talking about in the next slide here. The PL layer one is PL layer, and it is at client facing, but it is not installed. Remember, on the user end, and we need a third-party interface like browser to access this application, right? So see, any web application you cannot access without a browser. You have to have a browser to access a web application. Okay. So that is what thin client. Then we have so layer one is towards user facing, and then layer two BL layer and DML layer are on backend of the server, that is centralized. Then we have thick client application. So like mobile apps, desktop apps. In desktop apps, we have train ticket booking, clerk app, banking app, restaurant order accepting app. These all are example of thick client. A thick client application has two-tier architecture. The one tier, yeah, two-tier architecture. So layer one, which is the combination of BL layer and PL layer, is treated as one layer. Okay, and it is at which is can also be called as client layer, right? So that is one layer, and then there is a database layer, second layer, so two layers, right? So this layer, client layer, is generally installed on client machine, right? And DML layer, database layer, is centralized here also. That is common centralized, and there is no involvement of any third-party interface to access this application. It's like here we need a browser to access, but here we do not need a browser to access those applications. Okay. So mobile application is one great example of that. So let us understand the difference here. So see, we will take the example of same ICICI Bank. So we have mobile app also, ICICI mobile app, which is suppose APK file, or which we can download from Android or iOS. iOS mobile app, yeah, correct. And then we have web version also. Web. To access the web, we have to open the browser, and through browser we access it, right? Just now I have shown. And then for mobile app, we download that app, we keep it in our device, mobile device. And first time we have to do registration. And once registration is done, then we do not need anything, right? You just do authentication, maybe your PIN or finger, and then you are inside your app, and you are doing anything inside that, right? So that is so you see the difference. So you are getting so here you will be able to understand what I tried to say here is that not install and install, right? What is the meaning of? So this thin client application, the browser based application, nothing is installed on a computer or a laptop, right? We are using a browser, and through that we are accessing the application, correct? But here you see that whole application file, the setup is installed, which is almost it will be like 760 MB, 70 MB of file of any application nowadays, right? And they properly get downloaded, properly get installed, right? And once we do the setup, then we are inside it. So we do not need any browser and other thing to activate to access those things, right? So that's why there only two layer is there. One is client layer and one is DB layer, database layer. So that is two-tier architecture, okay, which we have, which I have shown here also. Okay. And the three-tier is what the modern web application architecture, right? Where proper uh, uh, three layers, PL layer, and DML layer. Now, always remember here I just said that PL layer and BL layer are almost treated as one layer, and database is another layer. Here, proper three layers are separate. Now, database is always separate because database, and it's always only one. It's only one. because it's the main thing, right? So database cannot be two different setup, right? It's a common setup. Database server can be many, right? They can be multiple, but the setup will be same. Okay, because suppose through mobile you have transferred 10,000, so it has to reflect in web also, right? Suppose you are accessing through web application, or suppose you have access through web application and you have transferred 10,000, so it will show here also. So how it will show? Because everything will reflect in and be stored or saved in database, right? So that is the examples. There are some many other example of two-tier architecture as well, but you might be not be aware of them. One train ticket booking clerk app is there, bank employee app, restaurant order booking app is there. So this used to exist earlier, but nowadays everything is moving on cloud. So all is becoming kind of web application only, right? One from after this revolution of cloud has came, na, WSW. So people are now migrating everything on the cloud. So mostly all bank app and restaurant accepting app all are going to become a web app only. But even train ticket booking app, if anyone is aware, I'll give you example of this. So do you know that we have train ticket booking people are there, right, on every station, railway station, right? Now railway station, we have IRCTC also, IRCTC, which is a web application. Then we have a mobile application of that. Now recently government has launched a mobile application also. But let us focus on web, right? Web is there from long time. Mobile now just recently it has came. And then railway employee is also there, right? Who is booking ticket on every station. Now, if you have any time, right, or even on YouTube or anything, just go and see this station people, which application they are using to book the ticket. Okay, so they are using still one DOS operating system. DOS setup is there. Okay, DOS is command-based tool. It was designed, and still they are using that one. If you have any time, just you visit any railway station, try to go and just see, or ask them if you are buying a ticket that which. Ask them, are you people using IRCTC to book the ticket? For me, no. Actually, they will not be. They have a different setup. Okay, so those are called standalone desktop apps, because that whole setup is installed in his machine, right? So you can book a ticket for a train, let us say Rajdhani or Bande Bharat. Suppose you are going from Bangalore to Chennai or Hyderabad to IRCTC also, and through that app also those people, station people can also book it. Okay, so database is same somewhere, right? But the mode of accessing is different, right? So like that earlier banking employee used to have a separate app. The bank, this ICICI that we see is for us, okay, for user. But the same ICICI employee, if you go and see, they will be using a totally different uh, setup, okay. And that was a region. Now also it is there, I believe, right? So, and which is dedicated to almost their laptop or their machine also. So that is the reason you might have heard that no banking employee, they do not never do work from home, right? Even in COVID time, they never did work from home. Why? Because they were not allowed to take their laptop because of security reason to their home, and all the setup used to be on that machine only, which is there in their premises, okay, which is not allowed to get carried over and all those things, right? So these things are there. Even this restaurant order, this you can see anywhere. So suppose you are there in any city, and there is nearby, if you have a very famous restaurant who is accepting order, so let us say Swiggy order. So Swiggy and Zomato has a web user interface, mobile user interface, that is for users, right? But when you submit the order is going to restaurant people, they have a different interface, okay. And so that you can go and easily see them. Any counter, if you go and just check their Swiggy counter where they're accepting the order. Okay. So you'll see they're completely using some total different setup, especially there is that is on a separate dedicated device will be there. Okay, on that, right? So those are called desktop apps. Desktop means that is special configured in one machine, right? A standalone machine where only two architecture will be there. One architecture will be the component which will be installed on that machine, right? The train ticket bank, that station machine, right? His machine, or banking people machine, or like food booking, those restaurant machine, right? So that is installed, right? Installed. So here we, right? That is specially kept. So that is what, and database is centralized just to reflect the orders. Correct. So that is there. So these are called desktop apps, mobile apps. They follow two-tier architecture, and web apps follow three-tier architecture. Now, this is one simple example of multi-tier architecture, how things work. So you can see here, this is divided into proper three-layer. Here database is totally separate. Then here app servers are there. Then here web servers are there. Some firewalls are also there, and here again web servers are there. So why this setup is done? So this is done for two peoples. One is for web users. So web users properly access the application through web interface. Firewall will be there, and then the request goes, and then it comes here, and then like this whole processing happens to them. And for internal user or the app user, right? Those mobile app users. So they have only one architecture, correct? They do not have separate web server kind of thing. This is treated as one for them. So one layer is almost reduced. So it is shown like that. Okay. Then so some real-time example of any application. So as I said, right, every application some blueprint on which tools and technology is made. So we have to know that before doing performance study to have an idea. So this is one example of one application whose your web servers is there here. This is app server, API server, you can say web server, and we have DB server, right? This whole setup is hosted or kept on AWS cloud, because as I say, now every application nowadays they are moving on cloud, right? So cloud. Now, this is web server. Web server is there on Windows OS, right? Windows AC2. For an example, two web servers are there. Load balancer. Then this is app server. App server is on Linux OS. Here also load balancer. Then Redis is there for caching, right? So caching that we have understood in last session, right? Caching is there in on browser also, on application side also caching things are there. And last layer is this DB layer, right? In that also primary DB, secondary DB is there. Okay. So you can see here a proper user who is accessing this application through internet, he access it through browser, that request to here it comes here, then gets segregated from there, it comes here, right? You can see. Then it got response goes back to, and but for a mobile user, they do not follow this system, right? Because they have the app installed. So these two layers almost become one layer to them. So directly request comes here, and it got processed, and this goes back, right? Response goes back. Then there are some other stuff as well. Then this is one example of this a application which is on Microsoft Azure cloud, right? Uh, so this is UI layer, BL layer, and again database layer. So UI layer is made up of AngularJS, .NET, right? Then this is all like Windows, all around Windows Server OS only. Windows Server OS. Database is here Microsoft SQL 2024, and then programming language used is .NET for this layer. AngularJS is for front end, right? And then HTTP, HTML, CSS, and JavaScript. So this AngularJS and all things are extended version of JavaScript for UI, and .NET is for this BL layer. So here we cover our core concept. So uh, now you'll be able to understand, like when we do anything, okay, complete one session when we do, or when we can't complete one business scenario, or yeah, business process, right? So there are some steps we have to do, right? And each step sends some request on the server. Server is also there in distributed form, right? Multiple servers are there, multiple layers are there, okay. And then server has a special mechanism of application OS, then network stuff. And this is how a load comes, right? And it got processed. And this is what happens in backend, right? In background, in terms of load testing or performance testing, right? So we complete this core concept today. Okay. Now, just, 5 days. 5 days. Fine. So next, uh, we will see this as well. So from tomorrow, we'll try to understand JMeter. Yeah. So JMeter will start from tomorrow. Okay. Right. So any question?
No, all good from my end.
Okay then. Take care. We'll meet. And yeah.